Hello everyone, just a minute. Okay. Hello everyone, a very good afternoon to all of you. So just let me know if my voice is audible to all of you. So in today's video, we are going to discuss the top MCQs from the question bank, from different district papers, from previous year questions about these chapters for midterm. Okay, so we have a lot of students online here, so thank you so much. And yes, if you haven't subscribed the channel, please subscribe it, because we are going to bring you the best content for your midterm preparation, for your KCET, final board, pre-board. Everything is going to be covered in this one channel, right? So please don't miss this. And yes, do let me know in the comment section if I'm audible. Yes, so students, just tell me, are you ready? When is your chemistry exam? First of all, you can tell me that. And how is your preparation going on? Is it good? And have you do you find MCQs difficult in your midterm exams? That also you can let me know. Yes, hi AT, hi Nishant, hi Rakshita. A very good afternoon to all of you. So students, are you ready? Shall we start the session now? Just tell me, are you ready? And please don't forget to subscribe the channel, and please send the video link to all your friends, because it is going to be a super entertaining session where we are going to solve the top MCQs and you will have a very good practice. Yes, so I have got so many yes that you all are ready for the classes. So students, we are having 6 chapters: solutions, electrochemistry, DNF block, coordination, then we have haloalkanes and haloarenes, and alcohols, phenols and ethers. Okay, so I have got so many yes: Sarag, Rakshita, Gavi, Keshav. So yes, tomorrow is the exam. For all the students who are having tomorrow's exam, let's get started without wasting any time. So I'll be bringing the first question here. So I've taken some questions directly from the question bank. Some questions are from your PU2 previous year questions, model question papers. So first question here, you have to you have to put the question number and answer. Okay, just put the question number and option. First question here is, which of the following is dependent on temperature? Which of the following? Yes, those of you have exam tomorrow, all the very best for all of you. So now coming to the first question, which of the yes, Gayatri and Mania has given me the correct answer. Yes, molarity. Can you tell me why it is like that? Because in molarity we have the term volume, right? And volume is something which can expand when temperature increases, so that is why the molarity decreases. Okay, yes, very good Sharag, Gayatri. I want everyone to participate. Everyone should answer the question. Second question, which of the following can be used as an antifreeze in automobile radiators? So is it methyl alcohol, nitrophenol, glycol, or ethyl alcohol? Yes, yes, next question. Sumati has given me the correct Sumati has given me answer. Sai, Krishna, Sachin. Yes, the correct answer here is actually glycol. Okay, it is glycol. Ethylene glycol or glycol can be used as an antifreeze. Now, yes, very good Rakshita, Prajwal, Raghavan. So good. Third question, the dissolution of gas in a liquid is governed by which law? Raoult's law, Henry's law, Dalton's law, or Van 't Hoff factor? So the dissolution of gas in a liquid, which law is used here? Yes, dissolution of gas in liquid, which law? We have to study, we study about this law so often. Can you answer this one? Yes, so many students are live. I want 100% participation from everyone. Yes, very good. Very good. It is Henry's law, option number B. Well done, students. Superb. You are going superb now. Coming to question number 4. Yes, this question is slightly on the trickier side. The mole fraction of the solute. Okay, the mole fraction of the solute in 1 molar. Sorry. Yeah, the mole fraction of the solute in 1 molar aqueous solution is. What is the mole fraction of the solute? Please solve this question. Take your time and solve this question. How to solve, I'll tell you. If you have no idea, please take your time and solve this question. The mole fraction of the solute. Yes, those who are saying option number B, that is absolutely correct. 4B is correct. So I'll just explain this question because it is slightly on the tougher side. So now if you see 1 molar solute, what do you mean by that? Number of moles of solute is 1 mole. okay, number of moles of solute. And if you see in 1 molal means the mass of the solvent is 1 kg. So what is the number of moles of solvent? Number of moles of solvent is 1000, that is 1 kg by 18, which is 55.55. Now if you want to calculate the mole fraction of the solute, okay, that will be equal to 1 by 55.55 plus 1. Okay, 1 by 56.5, which is equal to 0.018. Yes, yes, very good. 0.017. Sarag is absolutely correct here. Moving to the next question number, we'll move to question number 5 now. Out of the following, which is not an example of a solution? Is it air, brass, amalgam and benzene in water? So basically the question is asking you which is not an example of homogeneous solution. What will be the answer here? Which is not an example of homogeneous solution? So students, please do not forget to subscribe the channel. You can share the link to all your friends and let's have a group study here. So please subscribe the channel if you haven't, because we are bringing you content for KCET, Comet K, PU2, pre-boards, midterms, everything is going to be covered in this channel for all the subjects. So please don't miss out this one, okay? Yes, we have got answer. I have got answer. D is the correct answer actually, okay, which is not a solution. Okay, so benzene in water, this is not an homogeneous solution, so answer is option number D here. Yes, Prajwal, Sai Krishna here, Butterfly X, all of you are absolutely correct. Sumit Kumar, don't worry, we are also planning for PU1. We'll bring content for PU1 very soon. Okay, now coming to the next one, question number 6. If 1 mole of a substance is present in 1 kg of solvent, then it shows what? This is very simple question, my children. Only you have to just know the definition of concentration terms. So which is this one? I want everyone to put question number and then answer. Question number and then you have to answer the question. Yes, what is this one? It shows molar concentration, molal concentration, normality and strength. What is the correct answer here? D, gram by gram. Sachin, no, the 1 mole of a substance in 1 kg of solvent. Which concentration term is this one? Yes, Gayatri is absolutely correct. And Butterfly also. Sai Krishna, no dear, it is not molar concentration. In molar concentration, we have 1 liter of solution. Okay, 1 kg of solvent is molar concentration. Very good. Now let's move forward. Statement 1. On adding NaCl to water, its vapor pressure increases. That's the first statement. Statement 2 is addition of non-volatile solute increases the vapor pressure. So what? Both the statements 1 and 2 are correct. Both the statement 1 and 2 are wrong. Statement 1 is correct, 2 is incorrect, 1 is incorrect and 2 is correct. What is the correct answer here? On adding NaCl, yes, on adding NaCl to water, its vapor pressure increases. Is this correct? So please remember, you have studied colligative properties. The first colligative property, relative lowering of vapor pressure. Whenever you add a solute, the vapor pressure always decreases, right? So it will never increase. So this statement is wrong. Addition of non-volatile solute increases the vapor pressure? No, it decreases the vapor pressure. So both the statements are incorrect. So that is option number option number B. Both statement 1 and statement 2 are wrong. Okay. Question number 7 will be B. 7 is B. Why you all are people saying C? Any doubt here? So students, please remember, whenever we add a solute, the vapor pressure always decreases. Okay, vapor pressure will decrease. So that is why both the statements where it is saying that the vapor pressure increases is incorrect, right? Yes, B is correct. Sachin and Sai Krishna, you are correct now. Now let's solve question number 8 here. PA and PB are the vapor pressures of pure liquid components A and B respectively of an ideal solution. If XA represents the mole fraction of component A, the total pressure of the solution will be. So this is the question from Raoult's law. You have to see the expressions properly and then you have to solve it. So what is, try to solve it. So students, please put question number, then only I can know which question you are discussing, because there are so many questions coming. So please put question number and then put the option. Okay. So we have Raoult's law, according to which P total is equal to P naught A XA plus P naught B XB. Okay, now how will you approach the question? You can see that in all the options there is XA is present, right? So we have to keep XA, and I have to P naught A XA plus P naught B 1 minus XA. Okay, this has to be there. Next I have P naught A XA plus P naught B XA. Okay, now what I can do here, I can take P naught B, this term here, and here I can take XA common, and then I have P naught A minus P naught B, right? So I can just write down this option. So here which option is correct? P naught B plus XA PA minus PB. Okay, so I am getting option number D as the correct answer. Yes, all of you have got 8D. That is absolutely correct, and I am so happy that you have done this question correctly. Moving to the next question, question number 9, very simple question. Vapor pressure of two liquids P and Q are 80 and 60 torr respectively. The total vapor pressure solution obtained by mixing 3 mole of P and 2 mole of Q would be. Please calculate this one and tell me. And those who have not subscribed the channel, please subscribe the channel. As I told you, we are going to make the best content for your preparation for all the exams that are coming for you ahead. So just subscribe the channel and follow the content. This will definitely help you. And please share this video to all your friends so that let other students also join, your friends also join, and let's study together. Okay, so first of all, let me tell answer. Yeah, I have also got Shaila, Lakshmi, Sai Krishna, Akanksha, and all have given me the correct answers. So if you know what is the total pressure formula, it is P naught A XA plus P naught B XB. Okay, so what is P naught A value? P naught A value is almost P naught here, the pressure is of P and Q, right? So it is P and Q, X of P and Q, this is P and Q. So we have P is 80. Okay, what is the mole fraction? See, the moles of P is 3 and the total number of moles will be 5, right? That is the mole fraction 3 by 5 of P. Then we have here 60 into 2 by 5. Okay, so we have this one 48 here, and here I will get 1224. Okay, so that gives me 72 torr. So option number A is the correct answer. Yes. Next question number 10, last question from solutions chapter. The mixture which shows positive deviation from Raoult's law is. Mixture which shows positive deviation from Raoult's law is. What will be the answer here? Ethanol plus acetone, benzene plus toluene, acetone plus chloroform, or chloroethane plus bromoethane. 10A already Gayatri, Shai Krishna, Shailaja, Sharag has given me correct answer. Yes, ethanol plus acetone shows positive deviation from Raoult's law. Why? Because you know ethanol has strong hydrogen bonding, but when you add acetone to that, the hydrogen bonding between the ethanol's molecules is disrupted. Okay, good. Then let's move forward here to question next chapter, that is electrochemistry. Okay, very important chapter here. So we'll have quickly questions from here. The first question I hope is, which of the following statements is associated with electrochemical cell is incorrect? Okay, electrochemical cell is incorrect. So the function of a salt bridge in an electrochemical cell is to complete the circuit. Cell potential is the potential difference in a voltaic cell. A Bronsted-Lowry acid base reaction can be the basis of the net reaction in a chemical cell. A half cell reaction or half reaction corresponds to 1 electrode in a voltaic cell. Yes. What is the correct statement? Which is the incorrect statement here? Let me see who is answering this question quickly. Yes, students, please answer this question and please share the video with all your friends so that most of the students can prepare here. Sai Krishna has given not able to see. Okay, 1 second. Okay, I hope it is visible now. Which of the following statements associated with electrochemical cell is incorrect? Okay, so here are the statements that is given to you. The function of salt bridge in an electrochemical cell is to complete the circuit. That is the first statement. Is it correct or not? Yes, that is definitely correct. The potential, cell potential is the potential difference in a voltaic cell. Yes, that is also a correct statement. Bronsted-Lowry acid-base reaction can be the basis of the net reaction in the chemical cell. So if you remember that in a electrochemical cell, we use the redox reaction as the basis, not the Bronsted-Lowry reaction. So that is why option number C is the incorrect statement. A half reaction corresponds to 1 electrode in a voltaic cell. Yes, that is correct. You have oxidation half cell, you have reduction half cell, right? Oxidation half cell refers to anode, reduction half cell refers to cathode. So that is why here both the statements are correct. Okay, unknown, see, the midterm weightage will not be fixed here because there are 6 chapters and you have 70 marks paper. So there is no fixed midterm fixed questions how much mark they will give. But yes, the pattern will be constant. That is, from electrochemistry you will get 3 marker questions, 1 marker questions and numerical questions. Okay, yes, 1C is correct. Now let's move to question number 2 here. So I'll just second. Yeah, the standard electrode potential or E naught values of aluminium, silver, potassium and chromium are given to you respectively. The correct decreasing order of the reducing power of metal is. This is very important question. Okay, so you have been given, so I'll just note down the values. I think it is slightly not visible properly. So you have aluminium 3+2 aluminium. I'm writing the value so that we will also understand the question properly. Then you have K+2 K, okay, and you have Cr +3 to Cr. Okay, the values given here are -1.66 plus 0.80 minus 2.93 and we have minus 0.74. Okay, so now the question is asking the correct decreasing order of their reducing power. Okay, now please understand before you answer the question. The question is asking about reducing power, means it will reduce others. At that time, if it is reducing others, itself the species will undergo oxidation, right? So the species which can undergo oxidation better will be a stronger reducing agent. I just want to repeat the concept here. We have been given, we have to find out the strong element with strongest reducing power. It will reduce others. That means itself it will undergo oxidation. So the one which will undergo oxidation better will be the strongest reducing agent. Okay, so now if it is undergoing oxidation, these are all reduction potential values, right? If the species has to undergo oxidation, its reduction potential has to be least. So the values we have to check here is the least reduction potential. If the element is having least reduction potential, okay, means it will have strong, it has the higher tendency to get oxidized and at the same time it will behave as a stronger reducing agent. So which reduction potential is least here? I can see sodium reduction potential is least here. So sodium will be the first, sorry, it's not sodium, potassium. So I have 2 options with potassium. I'll eliminate these 2. Potassium, potassium I have. Next, what I can find out? Next, the lowest is for aluminium, right? So after potassium, I'll have aluminium, okay? That is present here also. After that, what I have? The next one is for chromium. So after potassium, aluminium, I will have chromium and lastly, I will have silver. So correct answer for this question will be option number C. 12C, those who have given, that is absolutely correct. Just let me know in the comment section if you have understood the concept or do you want me to repeat it. I will make sure that you understand this. Yes, Alish, you will definitely get 15 out of 15 if you do these 60 MCQs that I am making you practice now. Yeah. Just tell me, students, just put a thumbs up or just tell me no, let me know that understood. You just write on yes or something so that this is, you will get a lot of questions like this in this electrochemistry chapter. So do let me know if this concept is clear, if you are getting to understand this or not. Then only I'll move to the next question. Is this question clear to everyone watching this video? Or else please let me know. Understood. Okay, Sharag has given me a thumbs up. Shai Krishna, Prajwal, once again ma'am, repeat. Okay, Lakshmi is saying to repeat once again. So Lakshmi, just other students also please listen once again because this is important concept. Let's revise one more time. Okay, so the question is asking decreasing order of reducing power, means the species has to reduce others, right? Which element has the highest potential or highest power to reduce the other element. Now whenever a species reduces other element, it itself gets oxidized. Okay, so this is the species which gets oxidized will behave as a reducing agent, and the species which gets reduced will behave as an oxidizing agent. This is the fact. So now we want to find out the species which has the highest reducing power. If it is a reducing agent, it will undergo oxidation. So we have to find out the species which undergoes oxidation better. Now we have been given with the reduction potential of each element. So these are the reduction potential. So the element which will have the least reduction potential will have the highest oxidation potential. Means if potassium reduction potential is least, that means it undergoes oxidation better. If it undergoes oxidation better, it will be a stronger reducing agent. So that is why potassium comes here. Okay. Okay, I hope this is clear. Now let's move to the next question. A button cell is used in the watches function as the following. So there are two cells given to you. Zn, I hope that this is visible to you. I'll just zoom it a bit. Okay, so Zn2 plus E0 value is minus 0.76 volt, and there's a silver reaction which is undergoing. E0 is 0.34 volt. Okay, the cell potential will be how much you have to calculate. Okay, so you have two reaction. You can see the reaction here. Zn2 plus is getting converted, silver Ag plus is converted to Ag. So now the Zn2 plus value is minus 0.76, and for silver it is plus 0.34. So which one will be the cell potential here? That you have to find out. Yes, which is the cell potential? Can you calculate and tell me? Cell potential will be how much? Yes, cell potential will be how much? So you know what is the formula? Did I get any answer? 3C. Okay, I am getting C as the answer. Okay, just let me show once again. So you can see here that we have, see, Zn2 plus is in the reaction, Zn2 plus is undergoing oxidation. So oxidation is always anode, right? So I will have E0 of cathode minus E0 of anode, right? That has to be the formula. And Ag plus is undergoing reduction, so that has to be the cathode. So I have here 0.34 volt minus 0.76 volt. Okay, so 6 plus 4, 10. Here I have 11, so I'll get 1.1 volt, which is option number C. Yes, C is the correct answer, 1.1 volt. Okay, yes. Now let's move to question number 4 here. Again the question is on the basis of oxidation and reducing agent. Okay, so I'll just see the question here. Standard reduction potentials of the half cell reactions are given below. Okay, so you can see here F2 reduction potential, chlorine reduction potential, bromine reduction potential, and iodine reduction potential is given to you. Now you have to find out the strongest oxidizing and reducing agents respectively. Okay, so let us first find out without seeing the option. We have to find out strongest. Okay, we have to find out here strongest oxidizing agent and reducing agent. Okay, now see, oxidizing agent, the same concept. Okay, the same concept you have to use which we have discussed in this particular question. Okay, the same concept we have to use. Okay, so please try this question. Just try this question, I'll explain you. See, the question is asking you to find out the strongest oxidizing agent. Strongest oxidizing agent means it will oxidize others, itself it will get reduced, right? So strongest oxidizing, sorry, okay, just a minute. Okay, strongest oxidizing agent, it will oxidize others, itself it will get reduced. So the one whose reduction potential is very high, okay, whose reduction potential is very strong, it will easily get reduced and it will behave as a very strong oxidizing agent. So from the options you can see the reduction potentials are given. So whose reduction potential is maximum here? F2 reduction potential, if you see, yeah. So if you see F2 reduction potential, okay, just a minute. Okay, so if you see here F2, array, so students, I'm so sorry, just a minute. Okay, so if you see F2 reduction potential is highest, right? 2.85 volt is there. Okay, F2 reduction potential is highest. That means it will undergo reduction very easily and it will behave as a very strong oxidizing agent. And you see that there is only one option where we have A as the F2 is present in only one option. So definitely answer has to be option number A here. Okay, I don't know why is this. Okay, A is the answer here. Next, if you see the strongest reducing agent, now see, we have already identified the answer has to be I minus, but let's understand why this happens. Okay, the strongest reducing agent means it will reduce others, but itself it will get oxidized. If itself it will get oxidized, its oxidation potential should be very high or reduction potential should be very low. So the element with the lowest reduction potential here is this one, 0.53, right? So I minus will undergo oxidation to I2, so its reduction potential, or I can say the oxidation potential, is very high, so it is a strong reducing agent. So that is why option number A. Yes. Students, please tell me if this question is clear, because this is also a slightly confusing question. Just let me know if this question is clear in the comment section. Please quickly let me know, then we'll move to the next question. Yes. Do let me know if this question is clear to all of you. If it is clear, we'll move to the next question. Yes, Lakshmi has given me a yes. So I'll move to the next question. Again, the question is the standard reduction potential for SN4 plus to SN2 plus is 0.15 volt, and that of chromium plus 3, okay, this is chromium plus 3 to chromium, is 0.7 minus 0.74 volt. Those two couples in their standard state and are connected to a cell. The cell potential will be. Very, very important question. Please find the answer for this question. Yes, Sailaja has also given me a yes here. Okay. Thank you, Alish, so much, and this comment is really, really good. So please do follow the channel. We will be bringing up very good content for all of you. Okay, 15 already, 5 I have already got answer from Lakshmi and Sai Krishna. Let us see. So what you have to do is, why this question is important is to understand which is your cathode and which is your anode. So always remember, the one which is having more reduction potential, okay, high reduction potential, will be the cathode. Okay, high reduction potential will be the cathode. Now if I see here, SN is having higher reduction potential than chromium, so SN will be your cathode and chromium will be your anode. Okay, so now if I want to find the E naught of the cell, it is E naught of the cathode minus E naught of the anode. E naught of the cell is equal to E naught of cathode minus E naught of anode. So I will have 0.15 minus 0.74. Right, so if I'll add this one, I'll get 0.89, which is option number C here. Okay, fifth C. Vishnu, if your exam is tomorrow, then please do only important questions. Okay, I have done a live video on where I have discussed all the important questions, so just watch that video in 1.5x and revise all the important questions from all the chapters. Okay. Let's move to sixth question here. Consider the following relations for the EMF of an electrochemical cell. This is again very important question. So let me just give you some idea about this question. So when you have E naught of the cell, okay, the formula is E naught of oxidation plus E naught of reduction. Okay, and remember, oxidation takes place at anode and reduction takes place at cathode. Okay, now listen, if for anode oxidation potential is given, then you have to take positive. If for reduction potential, if for cathode the reduction potential is given, then that also will be taken positive. But for anode, if you are giving the reduction potential of the anode, then the sign will change. I'll explain with example, that will be more clear. See, EMF of the cell. Oxidation potential of anode, yes, at anode oxidation takes place, so that is why plus oxidation potential of anode, the sign will be plus. Minus reduction potential of cathode, no. See, in cathode reduction only takes place, and we are also talking about the reduction potential of cathode, so this one also has to be plus. Okay, so this, since it is given here minus, this equation is wrong. Okay, next I'll say EMF of the cell is Oxidation potential of anode, again oxidation potential, anode undergoes oxidation, so its value has to be given in positive, this part is correct. And reduction potential of cathode, plus reduction potential of cathode, yes, cathode undergoes reduction, so that is why here also I will have a positive sign. So yes, this equation is correct. Now let's talk about the third one, reduction potential of anode. See, at anode what happens? Oxidation takes place. But if you are talking about the reduction potential of anode, then the sign has to be negative here. But sign is given positive, so that is why this is also incorrect. Here if you see, yes, cathode undergoes reduction, so here positive sign is correct. But this part is wrong. Now moving to the fourth equation, oxidation potential of anode. Yes, anode undergoes oxidation, so positive sign here is correct. Oxidation potential of cathode, yes, now see, cathode undergoes actually reduction, but if you want to find out the oxidation potential, you have to take the negative sign, so that is why this one is minus. That is also correct. So we have this also correct. 2 and 4, which is option number D here. 2 and 4, option number D. Sai Krishna has given me the correct answer. So students, please tell me whether you are getting this question or do you want me to repeat this question. Yes, Maina Jain has given correct answer. Sharag Lakshmi, you people can also answer. Mohammed, Shailaja, Alish, Keshav, please everyone put down the answer and at least tell me whether this question is clear to all of you or not clear. If it is clear, just put a thumbs up or give some heart. I'll just understand. Okay, Sharag is saying me to repeat. Fine, let's repeat. I know this question is slightly confusing, so please understand properly. I'll repeat once again. Okay, so we have E naught of the cell, formula is E naught of oxidation plus E naught of reduction. Oxidation takes place at anode, reduction takes place at cathode. So if oxidation potential of anode is given, sign will be positive. Reduction potential of cathode is given, sign will be negative. A sign will be positive. Okay, sorry. Oxidation potential of anode, positive sign. Reduction potential of cathode is positive sign. Apart from this, anything else is given, like reduction potential of anode if you are taking, then the sign will change to negative. Oxidation potential of cathode if you are taking, then the sign will be negative. Okay, so what I am saying, for cathode, reduction potential if it is given, the sign should be positive. And for anode, oxidation potential if it is given, the sign has to be positive. In all other cases, means cathode oxidation potential or anode reduction potential if you are talking, the sign has to be negative in both the cases. Okay, now let's analyze all the options once again. Oxidation potential of anode. So anode undergoes oxidation, so oxidation potential is given, the sign is positive, so this is correct. But reduction potential of cathode, if cathode is there and it is, see, cathode undergoes reduction only, so reduction potential should have positive sign, but here it is negative sign, so this statement is wrong. Okay, now moving to the second one, oxidation potential of anode. Anode undergoes oxidation, so positive sign is correct. Cathode undergoes reduction, so positive sign is there. That is also correct, so this equation is correct. Now EMF of the cell is reduction potential of anode. See, when I talk anode reduction potential, sign has to be negative. Why? Because anode undergoes oxidation, not reduction. But you are talking about its reduction potential, so sign has to be negative, which is not given here, so that is why this is incorrect. Next, oxidation potential of anode. Yes, anode undergoes oxidation, so positive. And oxidation potential of cathode. Now see, here sign given is negative. Why? Because you can see oxidation potential of cathode has to be negative, so that is why this is also correct. So 2 and 4 is correct. Okay, I hope this is clear. Moving to the next question, seventh one, based on the E naught values, the strongest oxidizing agent is. Again the similar question, you have to find the strongest oxidizing agent. The E naught values are given. Okay, so here you can see that oxidation potentials are given. Okay, these are oxidation potentials and you have to find the strongest oxidizing agent. Be very, very careful and answer this question. Be very careful and answer this question. Huge chance of doing a mistake here. Yes. Oxidation potential. See, Strongest oxidizing agent means what? It will reduce itself, it will oxidize others, it will reduce itself. Now in this question, if you see, the oxidation potentials are given +2 to +3. Here it is +6 +3 to +2 to +3. Okay, this is 4 minus, so this is +2 to +3, this is also +2 to +3. So now if you see, if it is the strongest oxidizing agent, it will oxidize others, itself it will get reduced. So if it is undergoing reduction, its oxidation potential should be low. Okay, so whose oxidation potential is low here? Fe2+ to Fe3+ oxidation potential is low, right? So that means Fe2+ to Fe3+ reduction will take place. Okay, because the oxidation potential is less, so it will undergo reduction and it will behave as a strongest oxidizing agent. Now which one will undergo reduction, Fe2+ or Fe3+? Fe3+ will undergo reduction. So answer here has to be Fe3+, which is option number A. Yes, Lakshmi K is absolutely correct here. I know this question is slightly tricky. Just let me know if this is clear. Put down in the comment section a thumbs up or yes, or else I'll go to the next question. Yeah, Nagaraja is also correct here. Sai Dishan for prize you have to call to the call in our I'll say the contact number is given. You can just click on the link in the description section, then you will be directed to the KC90 page. There you can call and ask about all these details. Okay, moving to the next question. Which of the statements about a galvanic cell are not true? The cathode carries a positive sign, anions migrate towards the cathode, electrons are released through the anode, reduction occurs at anode. Which is not true? Let us go statement by statement. Cathode carries a positive sign. Yes, that is correct. In galvanic cell, anode is negative and cathode is positive. Let me tell you a very good mnemonic here that you should remember. Okay, LOAN. Anyone knows the meaning of this LOAN? Anyone knows? If you have taken my classes before, you would have definitely known about LOAN. Yes, L stands for left, O oxidation, A anode, N negative. Okay, so always remember, anode is negatively charged and cathode is positively charged. So this is correct. Anions migrate towards the cathode. In the electrochemical cell, anions do not migrate, electrons migrate. Okay, so this statement is wrong. Next, electrons are released through anode. Yes, on the anode side electrons are produced. So this is a correct statement. Reduction occurs at anode. No, oxidation occurs at anode. So this is also wrong. So 2 and 4 is incorrect, which is option number D here. Yes, Lakshmi K, very good, very good. Yes, 8D is the correct answer. Shailaja, correct. Next question, a solution of KBr is treated with each of the following. Which one would liberate bromine? Okay, so KBr, if you are reacting with all these options, okay, you will get bromine as one of the product. In which case you will get that? Let's see who is answering this question. This is slightly tricky question. Yes. Yes, the answer here is chlorine. Okay, chlorine is a stronger oxidizing agent than bromine. So chlorine Cl minus will oxidize bromine and itself it will get reduced. So that is why chlorine is the correct answer here. Okay, Lakshmi K is again absolutely correct. Now let's go to the last question of electrochemistry chapter. Electrolytic cells are electrochemical cells in which dash reactions are forced to occur by the input of electrical energy. Which type of reactions are forced to occur? Is it spontaneous, non-spontaneous, exothermic, endothermic? I want this question quick answer, my dear children. Within a fraction of a second you have to put the answer here. Quick. When you force something, which if a reaction is spontaneous, do you have to force it? No, right? When a reaction is non-spontaneous, at that time you have to force the reaction, right? So that is why option number B is the correct answer. And you might be knowing that in electrochemical cells or electrolytic cells, we have non-spontaneous reactions that are carried away by using electricity. Yes, 10B is absolutely correct. Lakshmi, Nagaraja, Akanksha and Shailaja, Gayatri, all of you are absolutely correct. Moving to the next chapter, D and F block. Let's see the first top 10 questions from here. So, among the following according to IUPAC, transition metals are defined as, okay, metals which have incomplete d subshell either in the neutral atom or in their ions, metals which have complete d subshell in the neutral only atom, metals which chemical properties are transitional between the S and P block, metals which with chemical properties were transitional between P and F block element. Shailaja has given, Mohan has given, all of you have given correct answer. Yes, option number A is the correct answer. Now see, metals with chemical properties with transition between S and P block is also correct, but that is not the IUPAC definition of transition elements. Okay, that is something which is observed. The D block elements properties are transitional between S and P block, but it is not the IUPAC definition. Okay, A is absolutely correct. Yes. So students, those who are new to the channel, please subscribe the channel because we are going to bring you the best content for all the exams that you are having. So please subscribe and share this video with as many friends as possible so that we all can study together. Now moving to the second question, the D block element not having general electronic configuration of n-1d 1 to 10 ns 1 to 2. This is a tricky question. Student who has attended my lecture or have read the book line by line can only answer this question. Yes, I have seen Mohan and Shailaja correct answer. 2B, palladium is the correct answer. Santosh, a new student here. Santosh has also given me the correct answer. Yes, Gayatri is also correct. Next question number 3. The electronic configuration of Cr is 3d5-4s1 instead of 3d4-4s2 is due to why? The energy gap between two sets 3d and 4s of orbitals is big enough to prevent the electron entering the 3d orbital. The energy gap between two sets 3d and 4s of orbitals is small enough to prevent the electron entering the 4s orbital. The energy gap between two sets is big enough to prevent the electron entering from 4s orbital. The energy gap between the two sets of orbitals is small enough to prevent the electron entering the 3d orbitals. Which one is correct here? Now see, first of all, 3d and 4s, the energy gap is small, okay, not high. So wherever it is given big enough, eliminate those options, right? Now what happens? From where the electron is entering? Electron is entering from 4s to 3d, right? The actual configuration should have been this one, but the 4s electrons comes from here to 3d, right? So the energy gap is small enough to prevent the electron from entering the 3d orbitals. Okay, the electron is entering to 3d orbital. So the gap is very small to prevent the electron from entering from 4s to 3d orbitals, right? I hope this is clear. Yes, those who are saying D are absolutely correct, my dear children. Let me tell you. Now let's move to the next question. Among copper, mercury, cadmium and Cn. Cn stands for copernicium. Okay, one metal is there, copernicium, which is not regarded as transition elements. Transition elements not regarded as transition elements. Copper only, mercury and cadmium. Mercury, cadmium and Cn, mercury, copper and Cn. So we know that Cu is a transition element. We all know that Cu is a transition element. So I can eliminate option A and D. Then which is the correct answer? For B I have got from Gayatri. Mohan is saying 4C. Okay. Yes, the correct answer is actually 4C because Cn is also an element which does not have any unpaired D electron in the ground state or in the excited state. So that is why 4C is the correct answer. Please correct this one, rectify this one. 4C will be the correct answer. Okay, not D. 4C beta. Those who are saying B, please correct it. It is C. Cn also does not have any unpaired electron. So this is also not a transition element. Okay, everyone please highlight this one. Moving to the next question number 5 here. The orbitals of the transition elements that protrude to the periphery of an atom more than the other orbitals. Which orbital is protruding out more in case of transition elements? So remember, it is asking about transition elements, not the inner transition elements. 5C, yes, d orbitals is correct. So d orbitals shape is so diffused, it protrudes out in case of transition elements. Next, moving to question number 6. The element having minimum volatility among the following is. Minimum volatility means they will have strong highest melting point, highest boiling point. Okay, volatility is very less. Which metal will be that? You can easily see which metal has the highest melting point in this. Can anyone guess the answer here? Option B, 6B, yes, tungsten is the correct answer. We know that it has the highest number of unpaired electrons. There is very strong intermetallic bonding, as a result of which the melting point and boiling point is very, very, very high. Moving to the next question number 7. The correct statement among the following is, you have to find the correct statement. Metals with very high enthalpy of atomization tend to be noble in their reactions. Metals with very low enthalpy of atomization tend to be noble in their reactions. Metals with very low enthalpy of ionization tend to be noble in their reactions. Metals with very high enthalpy of atomization tends to be highly reactive in their reactions. Yes, I have already got answer for 7, Shailaja and Komal. Komal has also given correct answer for 6th question, and 7th, yes. When there is high enthalpy of atomization, right? So the enthalpy of atomization means what? The energy required to break the atoms into elements. So when the reaction enthalpy of atomization is very high, the metals do not break or they do not react. So they behave as a noble gas. So that is why tend to be noble in their reactions. Option number A is correct. KMC, Gayatri, all of you are absolutely correct here. Let's move to question number 8 here. Metals of the 4D and 5D series have greater enthalpy of atomization than the corresponding elements of 3D series. More frequent metal-metal bonding are found in compounds of heavy transition metals. Identify the correct statement. Bharati and unknown, please put the question number and answer. All of you, please put the question number so that I can know the correct answer for which one you are answering actually. Okay, yes. Yeah, you know that enthalpy of atomization increases along the group, right? It increases along the group. So 4D and 5D will definitely have higher enthalpy of atomization, correct statement. And the reason behind here is for heavy metal, the metal-metal bonding is very strong. So both the statements are correct. Option number C. Yes, Sailaja, KMC, Gayatri, Anun, Lakshmi, all of you have given me the correct answer. Moving to the 9th question here, that in transition elements a regular decrease in the atomic radii is a result of filling of n-1f before nd orbital, filling of nf before n-1d orbital, filling of n-1f after nd, and filling of nf after n-1d. So students, please solve this question. Just let me have slightly of water. I'm very thirsty now. Yes, please tell me which is the correct answer for question number 9. Yes. No, not maybe. You are absolutely correct here. Sailaja and Art Gallery, all of you are absolutely correct. Filling of n-1f orbitals before nd orbitals. So what happens when n-1f orbital starts filling? The f orbital has very poor shielding effect, right? So the nuclear force increases and the size decreases here. Yes, Chinu is also correct here. Last question, the element with least density here is chromium, zinc, nickel and scandium. Element with least, yes, question number 10. Yes, question number 10, chromium, nickel, zinc and scandium. Let me see who has given the correct answer. 10C, 10D, yes. So please students remember Sailaja and Unknown, Mohan, Chinu, Gayatri, all of you are correct. Yes, scandium, as we move along the period, what happens? Masses increases and radius becomes smaller. So density is equal to what? Mass by volume. Mass is increasing and volume is decreasing. So both of them so what happens? As we move along the period, the density keeps on increasing and the lowest one is definitely here scandium. Okay. Yes. Yes, Komal, you are absolutely correct here. Now moving to the next chapter, coordination compounds. Again, first question. A purple compound M has a formula of CONH3 whole 6 Cl3. On adding excess of AgNO3 to 1 mole of M produces 2 moles of AgCl. If secondary valency of cobalt is 6, then the correct formula of the complex will be. Very, very important and good question. Please try this one. If the question is not visible, just let me know. I'll try. So please read the question. I hope it is visible. You are adding excess of AgNO3, okay? You are adding excess of AgNO3, and that is producing 2 moles of AgCl. So when 2 moles of AgCl is produced, that means 2 chlorine has to be outside the complex. First of all, you have to make sure that. So in which option you have 2 chlorine outside the complex? Here there is no 2 chlorine outside the complex. Here 3 chlorine are there, not there. Here possible, here possible. What is the next statement given? If the secondary valency of cobalt is 6, that means cobalt should form only 6 bonds. Here if you see, cobalt is having 6 NH3 and 1 Cl. So total secondary valency of cobalt is 7 here, which is also wrong. So that is why here, if you see, cobalt has 5 NH3 and 1 Cl. So 6 is the coordination number and 2 Cl is also outside. So option number C is the correct answer. Yes, Nishant, Prakriti, Advait, Shailaja, Rahul, Nishant, KMC, all of you are absolutely correct. Yes, unknown, I have a theory video. Please just check in the live session. We have a long video of at least 2 hours where I have discussed all the important questions and the answers. You can just skim through the video and just make a note of all the important questions. Okay. Next we'll go to question number 2. Which of the following is not a double salt? More salt, carnallite, potash alum, potassium ferrocyanide. Very simple question. We'll do it quickly. Yes, students, if you haven't subscribed the channel, I'm telling you once again, please do not forget to subscribe the channel, because this channel is going to help you in all your exams preparation, starting from PU2, midterm, final exam, pre-board, KCET, Comet K, all the exams are covered in this one channel. So do subscribe this one and do not forget to share this video with your friends. Yes, more salt, no dear, not a double salt. More salt is definitely a double salt. Why? Yes, Chinu has given me the correct answer. Potassium ferrocyanide, that is a complex. Okay, that is not a double salt. Yes, Komal, that is why we are doing a revision here. All the best for your exams. Nishant, Chinu, all of you are correct. Next question. The correct order of the stoichiometries of AgCl formed when AgNO3 in excess is treated with the complexes. So these are the complexes, okay? And with this you are adding AgNO3. So in what ratio AgCl will be produced? And the coordination valency is 6 here. So if you see the first question, COCl3 dot 6NH3. So what I can have, the formula can be like this. You can have 6NH3 here and Cl3 outside 3. So that will give you 3 moles of AgCl. So 3 moles of AgCl. I can eliminate these 2 options. Next, if you say 5NH3 and 3Cl is there. So what will be the formula here? I can have CO and I have NH3 5, right? And I have 1 Cl and then 2 Cl are outside, right? So that will give you 2 moles of AgCl. So after 3 I'll get 2 moles. So this is the correct answer, option number B here. Yes, Skanda EH has given me 3B. That is absolutely correct. Absolutely correct. Those who are telling B, it is absolutely correct. If this question is clear, please put a thumbs up. Yes, Nishant, Prakriti, Shailaja and Skanda, all of you have given me correct answer. Thank you, Ghost. Let's move to the next question. Which among the following has the highest molar conductivity? Yes, little bit tricky question. Highest molar conductivity which is having. So how will you identify? Where the number of ions produced is maximum, that will have the highest conductivity. Okay, you need to have the highest number of ions produced. Now if you see here, how many ions will be produced? I have already got answer. Okay, let me see. For this one, if you see, there will be 4 potassium ions and 1 this complex, as it is 1 ion will be remaining, right? So total ions produced here is 5. Now coming to here, you will have this complex as one particular ion, and there will be 3 chlorine ions produced. So the total number of ions produced here is 4. Next, here if you see, this complex will be 1 ion and SO4 will be 1 ion, so number of ions produced here is 2. Next, there is no auxiliary ion, so this complex remains 1 ion, or you can say just one compound, so there is 1 here. So which is having highest molar conductivity? Yes, Prakriti and Skanda are correct. 4A, because here you have more number of ions. Okay, molar conductivity, if you are studied in electrochemistry, depends on the number of ions present in 1 mole, right? Here the number of ions present is more, so that is why its conductivity will be maximum. Next, the primary and secondary valency of FeC2O4 whole 3 minus. Primary valency is how much and secondary valency is how much? Calculate this one quickly. Primary and secondary valencies. Primary and secondary valencies. So primary means the oxidation state of Fe. So here I can see this is X. C2O4 has a charge of -2. Okay, so -2. I'll have -2. How many C2O4 is there? Into 3. Okay, that is equal to -3. So I'll get X is equal to +3. So definitely the primary valency is 3 here. Okay, so I can eliminate option C and D. Now if you see coordination number, C2O4 is a didentate ligand. Didentate or bidentate means each C2O4 forms 2 bonds. So 3 C2O4 will form 6 bonds. So secondary valency is 6. So correct answer is option number B here. Yes, Nishant and Maina. Yes, secondary is not C, Prakriti. Secondary will be 6. Why 6? Please remember. Again I am saying this is a bidentate ligand. Okay, this is a bidentate ligand. Each C2O4 forms 2 bonds. So 3 C2O4 will form 6 bonds. Prakriti, is it clear to you? Please tell me if this concept is clear to all of you. Moving to the next question, question number 6 here. Coordination number of the central metal atom or ion is determined by. Coordination number is determined by only by the number of pi bonds formed by the ligands, both by the sigma and pi bonds, only by the number of sigma bonds, the total number of electrons present in the ligand. Yes. Okay, Prakriti is saying she has understood. 6D. Okay. Total number of present electrons, no. Okay. Let's see question number 6. Let me answer. All of you please answer. Yes, unknown, we will have similar revision for physics as well. Okay, yes, so Skanda has given me the correct answer here. It only depends on the number of sigma bonds. Okay, pi bonds does not have any role in determining the secondary valency. It is always the sigma bond. So number of sigma bonds formed by the metal and the ligand is equal to the secondary valency. Okay, yes, Prakriti, C is correct. Blossoming flora, no dear, not B. Not pi bonds. Pi bonds is not calculated or not considered for the secondary valency. Moving to the next question. This is very simple question and very important question as well. The correct IUPAC name of the following K3CrC2O43 is. Please try this question, everyone. Very simple, and most of you will get question from nomenclature. Definitely guaranteed question on the chapter of coordination compounds. Nomenclature question is very, very, very important. So do answer this one quickly. Yes. So what will be the C? I am getting a lot of answers. So let us see. First of all, definitely it is potassium. Potassium. Here also I have potassium. Here also I have potassium. Next, here I have, yeah, trisoxaleto, trioxaleto. So first of all, if you see chromium, okay, it's a part of an anionic complex. So name has to end with ATE. Okay, so I can find here ATE. Here I can find ATE and here I can find ATE, but here there is no ATE, so I can eliminate. One second. Yeah, so I can eliminate option number A. Next, what is the difference here? Oxalato, chromate, 3. Okay, here tri is not given, so this is also wrong. Okay, now between tris and tri, so what we will have? Yes, for oxalato we use the word tri, not tris. Okay, so that is why trioxalato, option number B here. Yes, Prakriti is absolutely correct. Okay. Yes. Okay, just a minute. Okay. So students, so sorry. Okay, just a minute. Tris, here tri is used, here tris is used, right? In IUPSC nomenclature, we use the word tris for this one, not tri. Very sorry. This is not one. This is the one correct. Okay, tris oxalato is the correct one. Yes, Prakriti, you are absolutely correct. C is my bad. I'm so sorry. It is tris oxalato. Okay, tris oxalato. Moving to the question number 8 here. PTNH3 whole 4 Cl2 Br2 complex can show what type of isomerism? Nomenclature and isomerism are very important topics. Do not skip it. So please see, can it show hydrated isomerism? For hydrated isomerism, you need water molecules. There is no water molecules here, so no hydrated isomerism. Ionization as well as geometrical isomerism. Yes, we can have ionization isomerism because these ligands can exchange, and this compound can show both cis and trans isomer. So yes, geometrical isomers is also possible. So here B is possible. Linkage isomerism. For linkage isomerism, we need an ambidentate ligand, but there is no ambidentate ligand here, so this is also incorrect. Ionization as well as optical isomerism. So here the whole molecule will not show optical isomerism. The cis isomer will show the optical isomerism. So most preferred answer will be option number B here. Yes, Nishant, Prakriti, Shailaja, Blossom, all of you are correct. Possible isomerism in complex, this one, CONH3 whole 3 NO2 whole 2 and CONH3 whole 5 NO2 Cl2 respectively are. What is the possible isomers in both of them? So here can we have linkage? Yes, NO2 is there, ambidentate. Okay, NO2 is there, which is an ambidentate ligand, so definitely we can have linkage isomerism in the first one. Then in the second one, okay, in this first one, we can also have geometrical isomerism. So can you tell me what type of geometrical isomerism are found in this particular compound? It is not cis and trans, it is something different. Can you tell me what type of geometrical isomerism is found here? Anyone can answer me this one? Anyone can tell me what type of geometrical isomerism is found in this particular compound? MA3B3 type. MA3B3 type. So if you remember, it shows facial and meridional isomers. Okay, so definitely this compound can show geometrical isomer, and this compound, since it is having NO2 group, it can show linkage isomerism. So that is why option number B is correct. Okay, this compound, second compound, does not show optical isomerism, so this is wrong. Okay, and this compound does not show geometrical isomerism, so this is also incorrect. Option number B. Yes, who is okay, I have already corrected. Yes, for 7th one, C is the correct answer. Tris oxalato is the correct answer. Okay, anybody? I first told B, but yes, I have corrected it. It is C. Okay, any doubt? Please remember it is C. Next we have question number 10 here. In the reaction COCl2 NH3 whole 4 plus Cl minus COCl3 NH3 whole 3, two isomers of product are obtained in the initial complexes. So always remember, when you find, when two products are formed, so what exactly is happening here? Slowly the NH3 group is replacing, the chlorine group is replacing the NH3 group. Okay, so when this process is forming, you will get a situation where you will have 4 Cl group and 2 NH3 group. At that time, there is a possibility that cis and trans isomer is possible, and always remember that the cis isomer is formed first. Okay, 10A, yes. Okay, Nishant, I will check this. Okay, Nishant, I'll check this and update. Okay, just give me, I'll check once again 7th question and I'll update. 10th one is A. Nishant is correct here. Okay. Fine. Other students, 10 question, all of you answer. Now let's move to the next question. Quickly, I'll discuss these questions of haloalkanes and haloarenes. Nishant, I will check. Okay, please don't worry, I'll check this one. Next, chlorine containing antibiotic produced by microorganisms which is very effective for the treatment of typhoid fever. What is used here? Typhoid fever. Typhoid fever, which is the correct answer? Shailaja is absolutely correct here. Chloramphenicol. Halogen contain compound used in the anesthetic drug. I'll go fast here. I'll go little bit fast here because you have exams, you need to revise also. So let's complete this. 10 and 20 questions are left. Within 20 minutes we'll finish it. Okay. So halogen containing used as an anesthetic during surgery. 2 questions. Second question, which is the correct answer? Anesthetic. 2C. Yes. No. 2D is the correct answer. Halothane is used as an anesthetic. Okay. Nishant, please correct. Yeah, Nishant is correct. Prakriti, not chloroquine. It is halothane. Okay. Okay, next question. 1,1-dichloroethane is called as 1,1-dichloroethane. You have dichloroethane. This is what will be the common name for this one? Ethylene chloride, ethylene dichloride, ethane chloride, or pyrene. What is the correct answer here? 3A. No dear, 3A is wrong. 3C is correct. Okay, ethylene chloride is used. Sorry, my bad. Yes, A is the correct answer here. A is the correct answer. This is for geminal dihalides. Okay, for geminal dihalides we use ethylene chloride, and for vicinal dihalides, okay, for vicinal dihalides you will use ethylene dichloride. Okay, moving to the question number 4. The total number of structural isomers. 3A is correct. All of you are correct. 3A is correct. The total number of structural isomers possible for the compound having molecular formula C5H11Br. C5H11Br. Total number of structural isomers. Just find it out and tell me. 4C. Yes, 4C is correct. So just let me tell you how will you get. So see, suppose I have this 5 carbon. Okay, this is on first position 1 bromine, that is 1 isomer. Then you have on second position 1 bromine, and you have third position 1 bromine. Okay, so I have got 3 isomers here. Now after that you can have a chain of 4 carbons. Okay, now here I had a chain of 5 carbon. Now I'll have a chain of 4 carbon, and 1 carbon is in the branch. Now in this you can have bromine at this position, that will be 1 isomer, and here is the same one, you can have bromine at this position. So 1, 2, 3, here 4, here 5. If you add bromine here, that is 6. If you add bromine here, that is 7. And one more isomer you can get is like this. If you draw, and any carbon you attach a bromine, that is your 8th isomer. So total you will get 8. So 4C is the correct answer. 5th one, which among the following has a chiral carbon? Chiral carbon means all the carbons, all the groups attached to the carbon should be a different carbon. Yes, so all the groups should have different carbons. So 2-chloropropane, is it an chiral? No. 2-chloropropane. So let me just clear the screen here. 2-chloropropane. Okay, so you can see this side we have methyl group, so this is not a chiral carbon. 3-chloropentane. If you have 3-chloropentane, you can see both the sides again you have ethyl group, so that is also not chiral. 2-chlorobutane. If you have 2-chlorobutane. Now here you said methyl group, here you have ethyl group, here you have chlorine, and here you have H group. So all the 4 groups are definitely different. So this is a chiral group. So the correct answer here is C. 5C. Yes, Prakriti, Lakshmi, Nishan, Chinu, Blossoming, Unknown, Shailaja, all of you are correct. 6th question, let us do 5 more questions quickly. The alkyl compound having the largest CX bond length. Largest CX bond length. Where you will have the largest CX bond length? CH3Cl, CH3I, CH3Br, CH3F. Yes, Nishant is very good. CH3I, because iodine size is bigger, so the bond length will be higher here. Yes, Chinu is also correct. Shailaja is also correct. Alkyl compounds having largest CS bond enthalpy means where the bond is very strong. Which is that one? CH3Cl, CH3Br, CH3I, CH3F. Seventh one. Yes, Nishant is almost correct in all the questions. Prakriti is also correct. Skanda is also correct. Komal is also correct. Manya, Jain is also correct. Chinu is also correct. Wonderful, my dear children. Yes, you know here the fluorine size is very small. So the bond length is very short, or this is a very short bond. So what happens? The bond enthalpy is very higher. Okay. No, dear Komal and blossoming, it is option number D here. Okay, the alkyl compound having the least dipole moment means where the electronegativity will be least, that will have the least dipole moment. Yes, Lakshmi 8C. Yes, CH3I is almost correct here. Again, Nishant has given me the first answer, least dipole moment, right? Least dipole moment, because iodine is least electronegative, you will have least dipole moment. Okay. Yes, Prime, definitely similar questions you can expect in your midterm exam. So do practice with me. You will definitely get similar questions. Next, we'll have the best reagent used to produce pure alkyl halides from alcohol. Very good question, this one. You know how to, this is also a very, I'll say, 2-marker question can also be expected here. The best reagent used to produce pure alkyl halide. Yes, Kanda's EH is correct, SOCl2. The reason being here, the products that we get is actually gaseous byproducts which can easily evaporate and your product is purified. Okay, yes. Next, last question. Aryl halide cannot be prepared from phenol because. The question is, if you know, if I have ROH, if I treat it with SOCl2, I'll get RCl. No doubt in that. But if you have phenol here and if you treat it with SOCl2, you won't get chlorobenzene here. Okay, this reaction is not possible. So the question asking you what is the reason for that. Phenol is more reactive than aryl halides. Aryl halides is more reactive than phenols. Carbon oxygen bond in phenol has a partial double bond character. Carbon oxygen bond in phenols has less bond energy. Yes, option number C, those who are saying. Yes, Prime, please put your question. Yes, Poma, you will get similar sessions for physics and bio as well. Okay. Teja, creative draw, all lesson important questions video is already there in the live session. You can definitely watch that. I have discussed all the important questions of all the chapters. Okay, now let's move to the next last chapter, alcohols, phenols and ethers. Okay, alcohols, phenols and ethers. First question, the COH bond angle in alcohol is. Yes, Prime, definitely paper will be easy. Do not worry. Just revise the last 10 questions with me and then do most important questions. Just revise all name reactions, mechanisms. It is going to be super easy question paper. Yes, I have got answer for 1B is slightly less than 109.28. Yes, when you have alcohols here, right, what happens? The lone pair of this one repel each other, so these bonds come together and this bond angle decreases, or it is slightly less than 109.28. Next, common name of this compound. Common name is asked, not the IUPAC name. Let's move to second question. Yes, blossoming flora. Yes, 1B I got already. 2A, Nishant, isopropyl alcohol. Yes, you can see this is a isopropyl alcohol. So students, if you haven't subscribed the channel yet, please subscribe the channel. I'm telling you, you are going to get the best content for physics, chemistry, maths, bio. We are also doing Kannada, English, and we will also be trying for computer science. So all the subjects for your midterm and final exams will be covered in this channel. So do not forget to subscribe it. Okay. Next, we have which of the following types of alcohols contain a bond between sp2 hybridized carbon and OH group. Which of the following types of alcohol contain a bond between sp2 hybridized carbon and an oxygen? Okay. So what is this type of alcohols called as? 3D. Yes, vinylic alcohols. That is absolutely correct here. Next, question number Prakriti, it is not B, it is D. Okay, yeah, you are correct. Which of the following term does not describe this one? Does not describe. Okay. Vinylic, primary, monohydric, allylic. Which one does not describe this one? Chinu, no, this is not tertiary. Okay. Which does not describe? Allylic. Skanda, no, this is allylic alcohol, beta. This is alcohol, right? This is allylic alcohol. You have an OH group after a double bonded carbon. Which is not defined. The question is does not describe. Does not describe. Yes, Nishant is correct here. So you see how tricky is this question. Does not describe. Definitely this is a primary alcohol. Okay, because it is attached to an sp3 carbon. This is monohydric because only one OH group is there. This is allylic also. But the only thing which is not applicable here is vinylic. And I know many of you have done this question wrong because you didn't read the question properly. Question is which does not describe. Allylic is something which describes it. Okay. Yes, Teja, definitely you can get. Which of the following compounds the OH group is bonded to aryl carbon? The OH group is bonded to aryl carbon. Yes, Supriya, we have already done a session, a live session is already done where I have discussed all important questions so that you will get 65 plus. Okay, that video is already there in the live session. You can go and watch that. In today's session, we are just doing the MCQs part. I have also discussed in yesterday's live session, I have also discussed what I'll say, the last year midterm paper, that also you can watch. Okay, 5B, bonded to aryl carbon, yes. Phenol is the one where we have aryl carbon because the structure of phenol is this one. Okay, oxygen is bonded to one aryl carbon. Last 5 questions here. ROR, where R is an alkyl group or aryl group, is the general formula of which compound? Oh my god, this is so simple question. Which is the general formula? ROR is the general formula will be of what? Komal Koshik, in this whatever comments we have received, majority of the children were having up to alcohols, phenols and ethers. So this video contains only up to alcohols, phenols and ethers. Yes, Prime, I am listening to your answer. 6C. 6C. No, my dear children, which general formula? Oh my god, 6C is completely wrong. Yes, D is absolutely correct. Ether group. Okay. Nishant and Nishant didn't expect this. Why is it C, dear? It is asking you, it is the general formula of which one? Okay. Yes, 6D is absolutely correct. Identify the simple ether from the following. Simple ether means from on the both the sides of the halides you will have same type of R group. Okay. So we have CH3, no problem, Nishant, no problem. Just be a little bit cautious while reading the question. Okay. So a simple ether, here is it a complex because we have different groups. Here also it is complex because we have different groups. Here you can find same groups on both the sides. Okay, so that is why this is a simple ether, that is option number C. Yes, Supriya, this time you said the answer is correct, definitely. So Supriya is the fastest here and all other students after that have answered correctly. IUPAC name of metacresol. So for this one you need to know the formula of cresol. So what is the structure of cresol? So if you know, this is OH and here I have CH3. Okay, so that is cresol structure. So Prakriti, Sailaja, Supriya all have given answer to me. So the answer is this one, cresol is 3-methyl phenol. 8A is the correct answer, 3-methyl phenol. Okay, 7, those were answering 7. I think there's a small, you are doing number error. 7th is this question, answer is C. For 7, the answer is C. Yes, unknown, you will get similar questions in midterm. Okay. Question number 8 is option number A. Okay. Yes. 7A. So dear C, what is this? Prime, please listen to me. In ether, simple ether means both the side of O, it should be same group. Same should be present on both the side of O. Here you have methyl and here you have ethyl. That is why this is not a simple ether. If you see option number C, you have C6H5, you have C6H5. Both are same. So that is why this is a simple ether. Okay. Prime, I hope this is clear. Okay, Supriya, I'm so sorry. I hope you can see now. Okay, question number 9, the correct IUPAC name of the following. You have to tell me the correct IUPAC name for the complete this one. 9B, okay, let's see. Yeah, I have to number from this side. Okay, so yes, I have 1, 2, 3, 4. So the formula here will be 2-methyl butane 2-OL, right? 2-methyl butane 2-OL. 9C is correct. 9C is correct, not 2,2-dimethyl, dear, not 2,2-dimethyl. You have to first find the longest carbon chain such that the substituent gets the least number. Okay, so 9C is correct answer. No, Komal, it is not B, it is C. You have to calculate this carbon also. Longest carbon chain you have to draw, and then the carbon with the CH3 group here. Okay, least OH group and CH3 group here. 2,2-dimethyl is not correct. You should have butane, means 2-methyl butane 2-OL. Okay. Yes, Supriya, we are going to the last question. The CO bond length in phenol is less than in methyl due to. Yes, last question. Okay. Let's see who is answering this question. 10D, I have got Sailaja answer correct. Partial double bond character of oxygen with aromatic ring. Yes, that is absolutely correct. sp2 hybridized carbon to which the oxygen is attached. Yes, that is also absolutely correct. So both A and B, which is option number D here. Okay. So yes, children, with this I am ending this session, but let me tell you few things which are very, very important. I have done a video on the numericals. Okay, I have solved almost 25 numericals from solutions and electrochemistry. Once you have done this, please watch that video, revise all the formulas, just solve the questions quickly. That is the first thing I want to tell you. And I'll also be making a video I'll be releasing by the end of the day where we'll be telling about the last minute revision. What all topics you should definitely revise before going to the exam tomorrow, that I will discuss in that video. So please do watch. And if you haven't subscribed the channel till now, do not forget to subscribe it. Okay. So just tell me, how was the session? Students, did you like the session? Did you like the session? Were the questions interesting? Please give me some feedback in the session. No, dear, no problem, Supriya. Nishant is saying super. Thank you, dear. Yes, okay. I hope all of you have enjoyed the session. And now let's get back to the studies. Those who are having exam tomorrow, all the very best. Please just feel free to comment any doubt you find tonight. If you want me to solve any of the questions, please put down in the comment section. I'll definitely address to all of your doubts. And those who are having exams later, do not worry. Many more sessions are coming for all of you. So thank you so much. All the best. Take care, and I hope that all of you are doing good in tomorrow's exam. And tomorrow, after the exam is over, we will be doing the paper discussion also. Around 4 p.m. we are planning to make the paper discussion, so do join that also. Thank you so much. All the best. Okay, just 1 second. Prakriti, yes, comment section of the main video, not in the live chat. In the main comment section, you can put down all your doubts. I'll clear all of that. You don't have to worry. Okay. Yes. Thank you so much.